Let's look at number 2, which says to determine which function has the greatest rate of change, justify with mathematical reasoning. And since this says the greatest rate of change, that is going to be the furthest from 0. So greatest rate of change, or the steepest, means the furthest from 0. And we have 2 points and then a table. And for both of these, we're going to use the slope formula. And so I'm going to just remind myself right here of what that is. And for the first one, I just have 2 points, so I'm just going to label them x1, y1, and x2, y2. And then I'm going to plug those into my formula. And so I get m equals y2, which is -6, minus y1, which is -2, over x2 minus x1. And so now I want to simplify this, and I can type this whole thing in my calculator, or I can do this part in my head. So minus a negative is a positive. And so we get -6 plus 2 is -4. And 6 minus 9 is -3. And a negative divided by a negative is a positive 4/3. So that is my slope for this function. Now with a table, you do almost the exact same thing, but you have some flexibility in which points you choose. So you can choose your 2 favorite, or the 2 that are going to be the easiest to do the slope formula. So I'm going to choose this point and this point, and the x's are on top, the y's are on bottom, so I can either rewrite it like this and do it the same way, or I can label x1, y1, x2, y2, and plug them into my formula that way. And so I have y2 minus y1 over x2 minus x1. -4 minus a -1, or -4 plus 1 is -3. And 4 minus 2 is 2. So I get -3 over 2. Again, fractions are pretty hard to compare, so I change them to decimals so that I can more easily compare them. So 4 divided by 3 is 1.3, repeating, and -3 divided by 2 is -1.5. And so in this case, it's asking us the greater rate of change, which is furthest from 0. And if I look at mine, this one is furthest from 0, which was the table. So I can say the table has the greatest rate of change because -1.5 is farther from 0 than 1.3 repeating. And that's your mathematical justification.